A MinCoin. Given a list of coins of distinct denominations and total amount of money, find the minimum number of coins required to make up that amount. Okay, output -1 if that money cannot be made up using given coins. You may assume that there are infinite number of coins of each type. So we are given some amount of coins different denominations, and we can make use of those denomination, those coins or those monies, and need to make a given amount. That is also provided in our question. So if we are able to make that amount, we need to find the minimum number of coins that we are required. Otherwise we need to return -1. So let's take 1 to 5. Okay, let's take 1, 2, 5. Okay, fine. So we need to make 11. So what are the different possibilities? Like we can take this 11, one coin, 1, 1, 1, 1, 1, 1, etc. up to 11 times. That's one possibility. The other possibility is we can take so many ones. Okay, say up to 8 coins have been taken. 3, 4, 5, 6, 7, 8. Then I can take a 2. Then again I can take a 1. Either way around. Or the other way is I can take so many 2, like 5, 2, and I can take 1 coin. All this will give us amount of 11. But one thing we need to look is that it's not about whether we can make that amount. We need to find two things: whether we can make that amount, and if we are able to make that a particular amount using these coins, we need to find the minimum number of coins. So in this case also, this is not minimum because we are making use of 11 coins. This also will not be minimum. This also will not be minimum. And one of the minimum will be taking 2 5s, which result in 1 and 1. So there is some kind, it's kind of a knapsack kind of a problem. If we see, like we are having two options in this, from this coins array, we are having two options. Like we can either take this coin or we can skip this coin. So if we take this coin, we will be adding it into our running coin sum. If we do not take it, it's fine, we move with the other one. And again we have two choices: we can either take it or we cannot take it. So based on that, we can go for the knapsack. And one more thing, here we are provided with infinite number of coins, so it's an unbounded knapsack. And thus there are different ways, it's a classic problem. The knapsack is a kind of very classical problem where we can apply recursion, we can apply 2D memoization plus recursion, we can make use of 2D tabulation, and there is also a 1D approach, okay, one-dimensional approach, where we will be tracking, where if we say dp of I, it will be tracking like the number of coins in order to reach that particular amount. So I will be directly going with the 1D optimized approach. There are different approaches that we can see in Geeks for Geeks itself, like knapsack is pretty classical problem. So here what we do means, in this 1D, the idea is, so again we have 1, 2, 5. So we will be considering a 1D DP table of size amount plus 1. And what is our amount? 11. So 11. So we will be considering 11 plus 1 because its index is 0 based. So if we need to consider the 11th index, like there should be 12 entries. So we are considering a large array, okay, and this is say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, so these are the indexes. Okay, these are the indexes. Perfect. So 1 2 3 4 5 6 7 8 9 10 11 12. So we will be taking a size of length 11 plus 2, that is amount plus 2, and we will be filling all the values except the 0 index with a large value than the current amount, the input amount. So we can consider an integer dot max value, or that value must be greater than the amount that is provided to us. So we can also consider 12 here. So we will be considering 12 to all these indexes except the first index, because for the first index we are having 0 amount. So let's say there is a minimum 0 amount of coin is required in order to make the amount 0. Like, we don't want any coins to make amount 0. It's pretty straightforward approach. So that's it. So the pseudocode will something look like this. Let me provide it here. So it will be something like for I equal to 1 till amount, okay, for j equal to 0 to the input array length, say n, okay, we will be checking whether the current amount, which is I, is greater than or equal to the input, the current index input. That is, say if the array is nums, it is nums of I. If that holds, okay, we will be updating our dp value. So say dp of the amount is equal to minimum of. So as I told, we have two options. We can either take this, consider this coin, or we can skip it. So we need to take the minimum optimal, which is the minimum from those two choices. So it will be minimum of, either dp of I, that means we are skipping, or it will be dp of I minus coins of j, and we are considering that, so plus 1. So this is the condition that we will be checking every time. So we are starting from here, the first amount. Okay, so we are here. Okay, we are here. So our j start from here. Okay, so is I, which is what is I, is 1. Is 1 is greater than or equal to this one? Yes, that's perfect. So the dp of I will be minimum of dp of I. What is minimum of the value of dp of I current? So 12. What is this? What will be this value? It will be dp of I minus coins of j. What is dp of I minus coins of j? I is 1 minus coins of j, this value. Okay, if the array is, sorry, I mixed it up. Let's say this is coins. Okay, so I am considering the input array as coins in array. So 1 minus the current j value is 1. So dp of 1 minus 1, which is 0, plus 1. So what is the minimum? Is 12 or 1 is the minimum? 1 is the minimum. So we will be updating this value with 1, because in order to get an amount 1, we used a single coin. Now we move to here. We are still at this position. So is 1 greater than or equal to 2? No. So we move to here. Is 1 greater than or equal to 5? No. So we done what with this. Now our I moves to here. So our j again start from 1. So the 0th index, that is the coin 1. So is this value 2 greater than or equal to 1? 2 is greater than or equal to 1. Perfect. So it will be minimum of 12 comma dp of what is the I is 2 minus what is the coins of j, 1. So dp of 1, what is dp of 1? 1 plus 1. So by making use of 2 1 coin, we were able to get an amount 2. Okay, now our j moves to this position. So our j moves to that position. After our j moves to that position, so again our I is at 2. Is 2 greater than or equal to 2? Yes, perfect. What is minimum of current dp of I? Our dp of I is 2. Okay, our dp of I minus coins of j. I is 2. So 2 minus coins of j is 2. 2 minus 2, 0 plus 1. So dp of 0 is 0 plus 1. So the minimum between 2 and 1. What is the minimum between 2 and 1? It's 1. So our value becomes 1. So this means we can make use of a single 2 coin in order to get an amount of 2. Perfect. So now we move to our j move to 5. Is 2 greater than or equal to 5? No. So we stop with that j iteration, and now our I move to 3. So now what? So again our I start from here, j start from here. Okay, so is 3 greater than or equal to 1? Yes. So we apply this approach. So we will be getting minimum of dp of 3, which will be 12 comma 3 minus coins of j. 3 minus 1, 2 plus 1. So using 3, that is 3 1 rupee coin, like we will be able to get 1 minute, yes, using 2 plus 1. So using 2 coins, like we will be able to get a value of 3. 2 coins, like 1 2 rupee coin and 1 rupee coin, we can use like that. Now our j moves to 2. Okay, our j moves to 2. So is 3 greater than or equal to 2? Yes, 3 is greater than or equal to 2. So what is the current dp of I value? It's 2. So dp of 3 minus 2 is 1 plus 1. It also gives value 2. So our dp of 3 remains as 2. Now we move to 4, and here also, like if we follow the same approach, like we will be getting what we will get, 4 is greater than or equal to 1. So what is the minimum of dp of 4, which is minimum of 12 comma dp of 3 plus 1. dp of 4 minus 1, which is 3. dp of 3 plus 1. dp of 3 is 2. 2 plus 1 is 3. So first we will update this value with 3. Okay, now our j will move to 2. Is 4 greater than or equal to 2? Yes. So our value will be dp of I, which is currently 3 comma dp of 4 minus 2. 4 minus 2 plus 1. So by making use of 2 coins, we can get an amount of 4. Like we can make use of two coins in order to get an amount of 4. So now we move to 5, but 5 is greater than or equal to 4. 4 is not greater than or equal to 5. So that condition fails. So we again start from the next amount. We reach amount 5. So is 5 greater than or equal to 1? Yes, 5 is greater than or equal to 1. So we will be taking the minimum of dp of I, dp of 5 comma dp of 5 minus 1, which is dp of 4 plus 1. So by making use of 3 coins, we will be able to get a amount of 5. Like we can make use of 2 rupee coin and 1 rupee coin. So our value of 5 gets updated as 3 currently. Okay, 3. Now my j moves to 2. So it will be minimum of once more, 5 is greater than or equal to 2. So it will be minimum of dp of 5 or dp of 5 minus 2, which is 3 plus 1, which is again 3. Now we reach 5. So dp of 5, 5 is greater than or equal to 5. So our dp of 5 will be updated as minimum of dp of 5, which is 3 currently, comma dp of 5 minus 5, which is 0 plus 1. So by making use of single 5 rupee coin, we can get an amount of 2. We can get an amount of 5, sorry. So a single coin is only required. So that's perfect. Now we move to 6. Same way, this will be updated as 5 plus 1. We can make use of 2 coins, so it will be 2. So this answer will be updated as 2. As we progress, like we can see, this value will be 2. Now in case of 7 also, the value will be 2. Like we can make use of 1 5 rupee, 1 2 rupee coin in order to get a value. Okay, now in order to get 8, we need to make use of 5, 2 and 1. So that time the answer will be 3. We need to make use of 3 coins in order to get an amount of 3. It's by just following, dry running this step we can get. So we reached 7, we reached 8. Now for 9, also we can make use of a single 5 and 2 2s in order to get an amount of 9. So there also the minimum number of coin in order to get an amount of 9 will be 3. Now to get 10, the optimum way is to make use of 2 5 rupees coin. So 2 5 rupees coin, and we will be getting the amount of 10 in by making use of just 2 5 rupee coin. Now let's get to the final, that is how many coins. That is also our question. So we solved some suboptimals problem and we finally reach our problem that is asked in our question. So that's the general way of doing a DP kind of a problem. So now we are at the amount 11. So how many number of coins are required for? Minimum number of coins are required. So 11 is greater than or equal to 1. So we will be updating this one, DP of 11, minimum of DP of 11, which is 12, or DP of 11 minus coins of J. So DP of 10, DP of 10 is 2, 2 plus 1, so 3. So minimum of 12 over 3, which is 3. So our 11 is now updated as 3. Okay, that's perfect. Okay, updated as 3. Now our J moves to the next value. So our J is now at 2. Is 11 greater than or equal to 2? Yes. So what is the, so we will be considering the minimum. So DP of 11 is 3 and DP of 11 minus 2, which is 9 plus 1, which is 4. It will be greater, so we will not be updating. Now we move to value 5. Okay, so the same way we will be taking 11 is greater than or equal to 5, so we will be getting inside this condition or this updation step. So DP of I is equal to minimum of DP of 11, which is 3, comma DP of 11 minus 5, which is 6, plus 1, which is also 3. So minimum of 3 comma 3, which is 3. So we have answer 3, and finally returning this value will give us a result. Now in some cases, like the number of coins might go beyond the given amount. Sometimes this will come to be 12 or 13, something like that in some cases. That's the place where we will be returning the output minus 1. Okay, so that's it. So that's, I'm directly going with the 1D approach. There is also a recursive approach, a 2D tabular approach, and the 2D recursive plus memorization approach, and the most optimal one is the space optimized will be a single D approach, a single array which shows amount plus 1. So let's have our DP, which is equal to new int of amount plus 1. So we will be storing a larger value in all the DP indexes except the 0th index. 0th index means because each of this DP will be holding the minimum number of coins in order to reach that particular coin. So in order to reach 0 amount, like we need 0 amount of coins. So that's why we'll be keeping the first value as 0 and all other values with some greater value, say amount plus 2. We can also give some integer plus integer dot max value, but amount plus 2 is also fine. So we filled this. Now let's have DP of 0 is equal to 0. Now as I return inside this pseudocode, the same way we will be providing I plus plus for int j is equal to 0, j less than, let's store the length equal to nums dot length, okay, less than length j plus plus. So this I will be holding the current amount and the j will be traversing through this current coin, like the nums of j will be giving the current coin. So if the current amount, which is I, is greater than or equal to say nums of j, so that's the place where we will be applying our updation to dp values. So dp of I is equal to mat.min of dp of I, which is the skip part. So we can either skip the current coin or we can consider the current coin. So we will be like taking the minimum from by considering both the operations. What happens if we consider that particular coin? What happens if we do not consider that particular coin? And what is the minimum between those? So that's the idea. So dp of I minus, this means we are considering that particular coin, so that much amount gets decreased, and we made use of one coin from that. Now finally the final check, if our final index, this final index is having some coin which is greater than the amount that we needed, then that's the place where we'll be returning -1, because it's already given in our question, output -1 if that money cannot be made up. So -1, else we will be returning the dp of amount. So the time complexity will be big of amount into the length of the array, and space complexity will be big of amount, because we are only making use of a single dp array. If we make use of 2D dp array, the time complexity will be big of amount into length of the array, and space complexity will also be big of amount into length of the array, and those are pretty available in gigs for gigs itself. Like we can study from this pretty classical knapsack problem. So yeah, I have coins. I see these coins and applied the same name there. So yeah, we are getting 3 3. Let's look whether we will be getting -1. So we have 2 and amount 7 and 2 and 6. By taking the sum itself, there is no way like we will be able to, yeah, -1. So let's submit. So that's it. So this is a pretty classical unbounded knapsack problem, and knapsack type itself. There are different types in knapsack. So here we can take infinite number of coins. There is no restrictions in taking only this much amount of coin. So it's a unbounded knapsack type problem. So that's the today's problem of the day.